All right, guys, let's go ahead and continue where we left off at the end of our lecture in class. So what we have right now is we're left here. 0 is equal to x squared plus 5x plus 4. Also keep in mind that this is an equation, so we usually have it as y is equal to x squared plus 5x plus 4, and we're setting the y is equal to up to 0. Okay, so why did I have it set up and left here? Why did I even try to get this? The original equation was the square root of x plus 5 is equal to x plus 3. Why did I try to make this into this? Well, right now, really when they say solve for a problem, you're trying to solve for the value of x, where if you plug in x into both sides of the equation, both sides will be equal. Let's think of some random numbers. I'm going to say 6. Why not? I'll make x equals 6. That means x equals 6 has to be replaced in both of these. Let's see if that's true. 6 plus 5, the square root, that would be 11. So that'd be the square root of 11 is equal to 6 plus 3, which is 9. That's not true. Okay, so that's not right. Let's come up with another number. I'm going to say x plus 10. 10 plus 5 is 15. The square root of 15 is equal to 10 plus 3. The square root of 15 does not equal 13. So you see how that way of solving for x is not easy and not good, and it takes forever because it's just random numbers. Well, if you set everything up where you square everything and you get all your terms, okay, because if I square both of these guys, I'll get x squared plus 3x plus 3x plus 9, and I get it on the other side. If I get all of these guys on here and you get on like one side, you set it equal to 0, there are techniques that we've learned in the beginning of this year to help us solve for the x values that will make this true, okay, both sides equal to each other, okay. And one of the ways what we do it is if we set it equal to 0, we can do what's called the quadratic formula. In order to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac divided by 2a, that is recalled upon what we did before in the beginning of the year, you have to recognize that if you have x squared plus 5x plus 4, you have something that has x squared, you have a number that's next to just x to the first power, and a constant number, you essentially have this form, ax squared plus bx plus c. In this case, this is the general form for these types of what we call quadratic equations. These quadratic equations, this is the quadratic formula, but these quadratic equations, in order to use a quadratic formula, are written in this way. C is some kind of constant. B is the number in front of an x, okay? And then A is the number that's in front of x squared. Though this looks like, so in this case, I will say C is equal to 4. My B is the number that's in front of the x. In this case, it'd be 5. B is equal to 5. And let's take a look at the number in front of x squared. Secretly, we think it's maybe 0, but it's not. Because if any number that's right next to the x, like let's go over here, b is equal to 5, you're actually looking at 5 times x in all of technicality. It's just that's not a real number. That's not really a real number. 5 times x. We know x could be equal to a number, but x itself, the letter, isn't really a number. So we just have as 5x, which represents 5 times x. Over here, a, if it was 0, that would be saying that 0, it would be 0 times x squared, which we know can't be true because 0 times anything would be 0. So a has to be 1. Does that make sense? Okay. We plug these values into here, and let's go ahead and continue that. So I could solve for, so this is, by the way, x. I'm trying to find values of x, and values of x that I think will be, you can, if you plug back into here, it will give me an answer. It will give me that both sides are true. This is the only way I can solve for those x values. So this is one way, is using the quadratic formula. There are other ways you could do this too, but this is one way that is always usually right. When it's very comprehensive. I don't know. I've taught you guys and students that this is the best way to actually do it by hand. It's just guaranteed to give you the answers as long as your math is correct. So x is equal to negative b, which I determined as 5, negative 5, plus or minus the square root of b squared. So b is, again, 5 squared, minus 4 times a, which is 1, and then c is 4. So 4 times 1 times 4, all over 2 times a, which is 1. That's going to be negative 5 plus or minus the square root of 25 minus 4 times 1 times 4. That's 16 all over 2 times 1, which is 2. Let's continue that. That's negative 5 plus or minus 25 minus 16 is 9 divided by 2. And then that'd be negative 5 plus or minus the square root of 9, which is 3. And then essentially, x can be two different numbers. Remember, all of this is equal to x. So just to reiterate, x can be negative 5 plus 3. Let's do that in our heads. That's negative 2 divided by 2. That's negative 1. And x could also be, if you did negative 5 minus 3. Negative 5 minus 3 is negative 8. You take negative 8 and divide it by 2, that will give me negative 4. These are two solutions for x that will make this possible. We'll make the square root of x plus 5 is equal to x plus 3. So in your book, okay, so anyways, sorry, before I move on, those are two possible answers. Those are two answers. Okay, you have that way to do that. That's one method of doing that. You've also been taught in the past, let me see if I can actually pull this up on your graphing calculator. Or you can even use Desmos. I like using Desmos. Let's go ahead and graph this. Okay. Let's go back up here. Right here to where I set this equal to 0. X squared plus 5x plus 4. So let's write in x squared plus 5 times x. Whoops, sorry. Let's go back one, back another one. Oh, let's delete this whole thing actually. Okay, there we go. Deleted that. And let's press x plus 4. I will graph that. The window is actually not too bad, but I want to go back to the original window. So I went back to zoom. I pressed 6 for standard zoom. That's pretty good. Then if you trace, I can kind of see it roughly. So what you're actually doing is, remember, go back to here. Before I applied the quadratic formula, I had this statement. X squared plus 5x is equal to 0. And then technically, you're looking at y, the equation y. Y is equal to 0. Your y point is equal to 0. So you're asking me where, follow my mouse, where on this parabola is y equal to 0? Well, everywhere y is equal to 0 on this line. So I'm asking you to find me what's called the x-intercepts of this parabola. Where is it the y value is 0? Well, I have it right approximately there. I know it's kind of hard to see, but I'm tracing it. This is actually a really small number. X is equal to negative 0.85. That's close to 0, and we're saying that y looks like it's about 0.46. It looks like about 0.5, like 1/2. I go over here and I trace, and I look at the other x where y is equal to 0. I can't really quite get it. Y is equal to, oh, sorry. So you know what? I think I read that wrong. Let's go back here. I'm trying to get to where y is equal to 0. I'm so sorry about that. So y is equal to about a half. And I noticed that the x coordinate is about negative 1, it looks like. Okay, look, my y is even getting closer to 0. Negative 0.187. That's pretty close to 0. And the x coordinate is about negative 1. And then over here, and look, just going back to, let's go back in my, look, didn't I find that the x value by hand was equal to negative 1? So you could really use the graphing calculator to do this as well, instead of solving it with the quadratic formula. And over here, I'm expecting negative 4, so let's go back on my graphing calculator. Look, I kind of traced it onto the x-intercept, and I noticed that y is about, when y is really close to 0, that's about 0.129. It's really small. It's close to 0. X is about negative 4. If you want to find the exact values, there's an option on your calculator to do this by pressing second graph. I'm sorry, it's not second graph. It's second calc, second trace right here. This trace one, second trace. And then you get to this nice little menu here. Go to 0. And then left boundaries. What you're going to do is you're going to trap your, like the x-intercept that you're looking for, like where it crosses x or the x-axis, or basically where your y is equal to 0 on this line, I want to I know that that point's right here. I want to make a left boundary to kind of like what is it? Kind of trap it in. So I'm going to pick the left boundary. So that means this little arrow saying in between here, and I'm going to go to it says right bound. Can you set a right boundary? I'm going to set, so to the right of the x-intercept, like, which is, I'm going to go a little bit further. Right here, this is, I'm going to press enter. It sets up, it's basically saying between these 2 points, it should calculate what the x-intercept will be. And I'll press enter for guess. Oh, look at that. It gives me the exact value, -4. That is the x-intercept. So instead of using the quadratic formula, like I did up here, if you can't memorize that and you want to do all this work, you have another option instead to use your graphing calculator over here. Okay? Use your graphing calculator over here to plug that in, or to get x equals -4. But remember, on this graph, I see another x-intercept. So I'm going to trace. I'm going to move over a little bit, and then I'm going to go second trace to get a more exact value. Let's go down 1. So that's, you can either press the number 2 or just enter, key in the enter. Set a left boundary to that x, or to that x-intercept. So I'm going to set it right here to the left. I'm going to press enter. Then I'm going to move my arrow to the right. So basically between these 2 boundaries, this left boundary and this right boundary, in between there lies my x-intercept. I press enter and it's going to calculate what that is. So you need to set the boundaries. That'd be -1. There you go. Yeah, so I found both the x-intercepts, okay, by using the calculator to find them. So you have 2 options. Either you can use the quadratic formula, or you can use your calculator, but you need to use your calculator very accurately. So anyways, I'm here. And what does this mean? So basically these 2 numbers mean that if I plugged it into the original equation, the square root of x plus 5 is equal to x plus 3, okay? Not with the squares, okay? If I plugged in both of these numbers, then it should be good. So what does that mean again? Okay, so let's play it again. So in your book, they ask you to do a check for your answer. So what is this going to look like? It's going to look like this. Write down the original equation, x plus 5 square root is equal to x plus 3, and then plug in -1 just to see if it is a good value. If it's a good value, it will make both of these sides equal to each other. We were trying to find a number that makes it so where if I plugged it into here and here, it would make the numbers on both sides equal to each other. Let's see if that happens. Let's do -1 and put in here. -1 plus 5 square root is equal to -1 plus 3. We get 4. The square root of 4 is equal to -1 plus 2, -1 plus 3, that's 2. And then the square root of 4. And this is where I do have to be a little bit more technical. That would be plus or minus 2 is equal to 2. And out of both these options, I see that positive 2 is indeed equal to, on this side was already a positive 2. This checks out. -1. So in your book, this would be an answer, okay? What I don't like about your book is this. It'll say that the other guy might not be the answer. The other one, the other x value that you found might not be an answer. And they'll say no. But let me see. -4 plus 5. Let's again substitute then that x with the other x value that we found out to be the answer. -4 plus 5 is equal to -4 plus 3. And -4 plus 5 would be just +1, square root of +1. And then -4 plus 3 would be -1. It already looks pretty bad. It looks like this. 1, you get the square root of 1 is just 1 is equal to -1. That, and in your book it says no, that is not. So x is not equal to -4. However, x is not equal to -4. So this, they say, is not a solution in your book. This gets a check mark, this doesn't. But I disagree, because the square root of 1 isn't just 1, it's plus or minus 1, just like the square root of 4 was plus or minus 2. So in that way, if I looked at just -1 is equal to -1, this still checks out. So if you are doing these problems in 4-5 in your book, please don't do the check, because I believe firmly that it doesn't matter what the numbers are here and here, it will always make the statement true. Okay, so you don't need to do the check part of any of these problems in 4-5. In fact, that's the only thing I want to show you in 4-5 that I'm going to test you on and I think is most important to learn from. Okay. Otherwise, guys, thank you guys so much for listening to this long video. You guys have a great day, and then prepare yourselves for the next week for more lessons. Okay. Thank you guys. Bye.